yttrium's been a key component for defense and for aerospace. And, since we made that announcement, I've had one of the largest aerospace and jet engine manufacturers in the world engage with Rainbow, looking for an offtake for yttrium specifically. And they also are happy to engage with floor pricing for the yttrium. So we see floor pricing now become more and more real in the rare earth space, and I see that continuing.
Hello, you're watching Proactive. I'm joined by George Bennett, the CEO of Rainbow Rare Earths. George, good to speak with you. How does finalizing solvent extraction as the separation route materially de-risk Phalaborwa for investors?
Well, Rainbow always had this sort of risk discount to it because we were going down the path of ion chromatography for our final separation route, which has never ever been done commercially on rare earths before. But we looked at this as an alternative because we were very afraid with solvent extraction as a team, and we were very afraid with continuous ion exchange. So we thought looking at ion chromatography as a low capital intense method of doing the final separation should be something that Rainbow looked at. So we went down that path for a couple of years, and we weren't getting our final purity and separation levels that we required. And so we made a decision a year ago to move our laboratory, or to move our pilot plant from Florida to South Africa. And we also made a very key decision, which is to build our own laboratory in South Africa, which enabled us to do test work at a fraction of the cost of using outside laboratories, which is significant. And also, very importantly, our turnaround time on test results now was in a matter of hours rather than taking 2 to 3 weeks. So with that, we were able to develop our flow sheet on much, much quicker at a very low cost to Rainbow. And we had great success in reducing our volumetric flow through continuous ion exchange to our final separation circuit. And we achieved a very, very high grade of final pregnant leach solution going into the final separation circuit, as well as very, very low levels of impurity. As I said, through all the work done in our lab earlier this year, and which we've announced those positive results to the market. But with that, we realize now that we could look at a solvent extraction circuit, which would be far smaller than if we hadn't had the success with the CIX and the impurity rejection that we achieved at Rainbow. So with that, we got hold of ANSTO, the Australian Nuclear Science and Technology Organization, that's a global leader in solvent extraction for rare earths in the world. And ANSTO probably designed most of these solvent extraction separation circuits for rare earths for most Western rare earth projects in development in the world today. So we'd worked with ANSTO before, initially on Phalaborwa with our leaching test results that we had achieved on the gypsum initially. And so ANSTO were aware of the Rainbow project very much so. And with that, with engaging with ANSTO, they confirmed in their report, which we received last week, that we would have the separation of neodymium and praseodymium at the purity levels required, 99.5% purity. And we would also achieve the separation of our SEG plus group, also at 99.5% purity. And that would be via 2 solvent extraction circuits. And these circuits would be very, very small circuits compared to your typical solvent extraction that you see with other projects globally. Quite often, rare earth projects have circuits 1,500 to even 2,000, what they call mixer settlers in the solvent extraction circuit. We can have combined with our NdPr circuit and our solvent and our SEG plus circuit, a total of 75 mixer settlers, which is very, very low in terms for this type of circuit. So it's confirmed that we're going to stay within the parameters of the low capital intensity for Rainbow, as well as low operating costs for Rainbow. We'll be still at the lowest end of the cost curve and at the highest end of the margin curve for our project at Phalaborwa. And as I said, this is a significant de-risking step for Rainbow because now we're using tried, proven, tested technology for the final separation.
George, we chatted about yttrium just a week or two ago. Prices have surged from $6 a kilogram to about $200 a kilogram. How does this translate into real upside for Phalaborwa's annual EBITDA, and how sustainable do you think this pricing environment is?
Well, actually, we've seen a higher pricing in contracts in Europe. We've seen between 220 and $320 a kg for yttrium. As I say, between 1,500 and 4,000% rise in price for yttrium. And with that, we've realized that, initially we were only looking at dysprosium and terbium, apart from the neodymium praseodymium, as adding value to the Phalaborwa project in terms of revenue and EBITDA. But now we've gone down the path of the SEG Plus group, and we're going to get value not only for our dysprosium and terbium, but also for the yttrium and our gadolinium in our SEG Plus group, as well as the samarium. We've seen our revenue contribution circa $160 million versus at a 70% payability for our SEG Plus group versus a revenue of $80 million just for the DyTb that we were forecasting. So it's a significant increase in our revenue, and at an EBITDA margin of over 70 to circa 75%, you can see that would be a significant contribution addition to our EBITDA as well. And in terms of pricing, so I've used in our announcement, I used the very low end of that price increase, which is at $220 a kg, to calculate the impact on our EBITDA and our revenue. As I say, we've seen much higher pricing, so we've been conservative, and we've used a conservative payability ratio of 70% for our SEG Plus group. We have been quoted higher payabilities in offtake discussions for Rainbow. So, those are conservative numbers, we believe, and they look very good for Rainbow. Now, the big question is, how sustainable is the price? Well, yttrium's been a key component for defense and for aerospace. And, since we made that announcement, I've had one of the largest aerospace and jet engine manufacturers in the world engage with Rainbow, looking for an offtake for yttrium specifically. And they also are happy to engage with floor pricing for the yttrium. So we see floor pricing now become more and more real in the rare earth space, and I see that continuing. And as I said, I think yttrium is always now going to be a very, very expensive rare earth compared to what it used to trade at, specifically because we know the Chinese are targeting yttrium as a rare earth that they will have export bans on because of its military applications. And the Chinese have been very clear in any rare earths that are useful in military applications, they will look very carefully at halting exports of those rare earths. So I think the price increase in yttrium is going to stay, I don't know if it'll be in the rarefied atmosphere the prices are currently, but it's still going to be a significant increase to what we've seen previously, and it will continue to add significant value to the Phalaborwa project, I believe.
And George, with ANSTO and Metsi Engineering now locked in on process design, what are the remaining technical milestones before the DFS is completed?
Well, to be honest with you, the key technical milestone was achieving separation and purity via ion chromatography. That milestone has now effectively been met because we've switched to solvent extraction, and ANSTO have confirmed our purity levels are going to be above the 99.5% that we're targeting, and we're going to produce the two separated products. So that technical milestone is now being met, which was a key milestone for Rainbow. So now it's just doing engineering and running a pilot plant at ANSTO, which we'll be doing next year, just to produce a product for marketing from a pilot plant they're going to run. The pilot plant will be very short, though. It'll be circa 7 days for the one circuit to produce the NdPr, another 7 days for the SEG Plus SX circuit to produce SEG Plus product for marketing. So from a technical aspect, there's nothing that I believe that is in the way of now completing our DFS circa the middle of 2026, and we've indicated to the market. Previously we could never define our DFS timeline because it was always predicated on achieving separation via ion chromatography. Because, how long's a piece of string? We could never be 100% certain when we'd achieve the purity and the separation of ion chromatography test work we were doing. Now that uncertainty has been taken out of it by going the SX route. So we've got a very defined timeline now that we are very happy to be able to focus on.
George, I hope you'll continue to keep us updated with your progress. Thank you very much for speaking with us today.
Thank you very much for having me on.
George Bennett, the CEO of Rainbow Rare Earths.